So in this lecture we talk about expressions made up using delimiters, constants, and operators. These are really important fundamental concepts that you have to get very clear about. And the way to get clear about things in programming is to practice. It's not enough simply to listen to a lecture. It's not enough simply to read what is being demonstrated or even to type it out yourself in Julia Box or iJulia. You also need to form your own expressions and see what happens if you try and make an expression with this or that form of delimiters, with this or that operator. And in this way, you start developing your ability to be expressive in the language. It's important to remember that it is a language. It is something to write meaningful expressions in. And that means that you have to have your own meaningful expressions and your own expressions in the language that you type out.
Week 1, Lecture 4, Arithmetical Expressions. Arithmetical expressions are, of course, at the heart of numerical computation. All of the time that we are using numbers, we have to combine them using arithmetical expressions. So let's look at some simple examples. Here we have 1 minus 2 plus 3 minus 4. We've seen how to do this in the REPL. We do Shift Enter, and the result is, of course, minus 2. Here we have 1 divided by 2, 3 divided by 4, and the result is a half plus a quarter. So we divide first, and then we add. If we wanted to do the addition first, we would put parentheses in, and now we have 1 divided by 5, so this is a quarter of 5. On the other hand, we can put parentheses to make sure that the last 3 numbers are first done, and the result is 0.36 or so. So this is actually, first we make 3 quarters, then it's 2 3/4. We divide 2 3/4 into 1, and we get that result. And finally, we can actually start from the left. We can have 1 divided by 2, which is a half. Then this is 3.5 over 4, and that's, of course, 0.875. So the topic here that we're interested in is operator precedence. The plus, the minus, and the divide operators can occur in many orders, and it can be ambiguous. So 1 divide by 2 divide by 3. What do we do first? From the left, it's 1 divided by 2 divided by 3, and from the right, it's 2 divided by 3, and we divide that into 1. So from the left, it is 1 over 6, and from the right, it is 3 over 2. In Julia, there's only one way to read it, from the left. Likewise, 2 minus 3 plus 4, that is 3 from the left. And from the right, it is minus 5, because this is 7, and 2 minus 7 is minus 5. But in Julia, it can only be 3. When it comes to this operator, what we will do in Julia is first we will take the power operator and make it into 8, and then divide by 2, and it makes 4. If we wanted 2 to the power 3/2, we would have to use parentheses. So let's see the results using println. Remember that println can do simple arithmetic. And here we see the results. I'm having some type comments here. Don't worry too much. We will talk much later about type. int64 is a type. float64 is a type. They will turn up later again. So the order of arithmetical operations then. The order precedence. First, we do the parentheses. So anything in parentheses done first. 3 over 2 before we do exponentiation. Then we do exponentiation. So 2 to the 3 is done before we do division by 2. And then finally, once all of those are sorted out, we have multiplication and subtraction and division and addition, and they divide into 2 parts. All of the multiplications and divisions are done from left to right, and then all of the additions and subtractions are done from left to right. Right, so here we have some code that mixes types. Don't worry too much about that. What we want to predict is exactly what Julia will do. Well, Julia will take all of the there are no parentheses, right? So that stage doesn't apply. There's no exponentiation. That stage doesn't apply. However, there is multiplication and division, so we have 3 times 6.7 multiplied by 4. Here we have 2 times 3. So this comes out to about 5, and this comes to 6, so we have 0.1 plus 0.2 is 0.3 minus 5, which is about 4.7 minus 1, which is about 5.7 minus 6, so it should be roughly minus 12, which it is. Let us illustrate how long the expressions can be. This is quite a long expression in Julia, doing an arithmetic. If we like, we can make it a lot longer. So I highlight that, I copy it, using some operator, I don't really care what, let's use the exponentiation in this case. I paste it in, and now let's evaluate that expression. I could repeat this whole exercise and make the expression extremely long. Julia will cope. Of course, for a human reader, we don't like to see hugely long arithmetical expressions, or indeed algebraic expressions, because they're difficult to read. But if we need to, we can do them in Julia.
Right, so that's the end of lecture 4. Long expressions are a challenge. You should go and practice expressions now. And why don't you try and make the longest expression you can possibly make, and possibly even succeed in crashing Julia?